All right, so going back to those rules about solving a radical equation. So like I said, we'd isolate one of the radical terms. So we're going to deal with two radical terms. So what we're going to do is isolate one, use a principles property, and now we're going to use step 3 here, which is when we isolate one radical, frequently the other one, another one's going to get left behind. So we will have another radical remaining. So we will have to repeat these steps again, and then we'll have to check for our solutions. So for an example, sorry, I was like trying to write with a real ink pen on my board here for a second. So for an example, we have this one right here. So we are going to have the square root of x plus 3 minus the square root of x minus 2 equals 1. And I need to isolate one of these radicals. So let's just pick this one because it's just a little easier, because all I have to do is add x square root of x plus 2 to both sides, or square root of x minus 2, sorry, and we cancel that out. And now I just have on one side, the square root of x plus 3 is going to be equal to 1 plus the square root of x minus 2. So the next step, as like before, I want to get rid of this radical, so I square here and here. So this is where we're going to see something a little different. So what this means is that the square root basically gets doubled. And because we have it twice, it essentially cancels itself out. So we're just left with the x plus 3. This side, however, is really just 1 plus the square root of x minus 2. And then we also have 1 plus the square root of x minus 2. So because it's not a radical, the radical is not by itself, I can't use this square root to just, or this square to get rid of that square root. It works on this side because this is essentially just saying that I have the square root of x plus 3 times the square root of x plus 3. That's all it is there. So we're just duplicating the square root, which is what gets rid of it. So what we're going to have is x plus 3. If we expand this, we're going to have 1 plus 1 times the square root of x minus 2. So we're going to have x square root of x minus 2. X minus 2 times 1 plus the square root of x minus 2. The square root of x minus 2 times the square root of x minus 2. Well, that is going to be the square root of x minus 2 squared because we have it twice. So we have x plus 3 is equal to 1 plus 2 times the square root of x minus 2. And then because this radical is squared, it's all by itself and isolated and squared, we have plus x minus 2. If we simplify one more step, x plus 3 equals x minus 1 plus 2 times the square root of x minus 2. All right, so for here, we're going to isolate the other square roots. We need to isolate this one. So if I subtract x from both sides and I add 1 to both sides, I'm going to end up with this x cancels out and I'm left with 4 equals, this cancels, equals 2 times the square root of x minus 2. And then if I divide by 2, I have 2 is equal to the square root of x minus 2. So now I isolated the radical, I could square both sides, and I'll have 4 is equal to x minus 2, meaning x is equal to 2. Okay, little typo here. This is a silly one. Right here, 4 is equal to x minus 2, so we add 2 to both sides, and then we have x is equal to 6. And the first thing, well, I know that's not what the answer is supposed to be. So we need to check the solution. So we go back to our original equation, and every place I had x now, I'm going to put in 6. So 6 plus 3, square root of 6 plus 3, minus the square root of 6 minus 2 equals 1. So we're going to have square root of 9 minus the square root of 4 equals 1, which is then 3 minus 2 equals 1, 1 equals 1. So my solution is x equals 6. That is my actual solution. Okay, so for this one, we're going to end up with a polynomial again. So fortunately here, we already have one of my radicals is isolated, so I can just go over that second step and just square. And if I do that, I'm going to end up with x minus 2 over here equals to negative 2 plus the square root of 2x plus 3 times negative 2 plus the square root of 2x plus 3. So x minus 2 is going to equal, if I distribute this, 4 minus 4 square root of 2x plus 3 plus square root of 2x plus 3 squared. Like I said, all I did is just this distribution here. So x minus 2 is going to be equal to 4 minus 4 square root of 2x plus 3. And then because I'm squaring just an isolated radical or isolated square root, these cancel and I'm just left with the 2x plus 3. Okay. So just a little simplifying here, 2x plus 7 minus 4 times 2x plus 3 equals x minus 2. So my next step here, I need to isolate this radical. So I can take away negative 2x from both sides, and I'm going to have negative x minus 2 equals 7 minus 4 square root of 2x plus 3. Then I can subtract 3 from both sides. And I'm going to have negative x minus 9 equals minus 4 square root of 2x plus 3. So if I divide both sides by negative 4, I'm going to leave it like this. I'm going to have negative x plus 9. So I just pull out negative 4 here, and then I isolate, and then in this side is equal to the square root of 2x plus 3. So from here, this is where I'm going to square again. So just as a reminder, we're squaring a negative here and a negative here. So this is going to be negative x plus 9 squared over negative 4 squared is equal to 2x plus 3. So what we get left with is x plus 9 squared, because like I said, that gets rid of that negative here essentially. And then on the bottom here, we just have 16. Another way you could have thought about it is I eliminate my negatives here, if that's a little easier to look at. And that gets rid of my negative here and here. Okay. So continuing, if I expand x plus 2 squared, that is going to be x squared plus 18x plus 81, all divided by 16, which equals, second, remove something here, equals 2x plus 3. So now I'm just really just solving for x. So We got the 16, so let's multiply both sides by 16 to get rid of it. So we got x squared plus 18x plus 81. So 16 times 2x is going to be 32x, and 16 times 3 is going to be plus 48. Make sure I got my numbers right. Yes. Then we just, like I said, we got a polynomial. So just isolate one side instead of, or just set one side equal to 0. So I'm going to subtract 32x from both sides. So x squared minus 14. X plus 8 equals 48. Oh, not 8, 81. And then it equals 48. Then I'm just going to subtract my 48. So I get x squared minus 14x plus 33 equals 0. So what this would factor into, oh, x minus 11, x minus 3. If you add those together, we get minus 14. Multiply and we get positive 33. So my possible solutions are going to be either x is going to be 3 or x is going to be 11. So we know what the next step is. We just have to check those two solutions. So we'll make some room over here, do some checking. I'll leave that last bit right there. So we're going to first check x equals 3. So we're going to have a square root of 3 minus 2 equals negative 2 plus the square root of 2 times 3 plus 3. That's going to give me the square root of 1 is equal to negative 2 plus the square root. So I don't know why I put those, those parentheses there. 6 plus 3, so we're going to have 9 there. So we're going to have 1 equals negative 2 plus the square root of 9. So square root of 1 we know is 1. Negative 2 plus 3 equals 1 plus 1. Yes, that works. This is a solution. Now we're going to check the other one because we don't know. It could be a solution. It could not. So x equals 11. So we're going to have the square root of 11 minus 2 equals minus 2 plus the square root of 2 times 11 plus 3. So this is the square root of 9 equals negative 2 plus 22 plus 3, so 25. So this is 3, negative 2 plus 5, and we get 3 plus 3. So in this case, once again, both are actually solutions. All right, so for 8, just do the same thing again. So A is going to be very similar to what we were seeing. B is a little different. Okay, so like I said, take a moment and then cause. So for A, we got one side, one radical is already isolated. So we don't have to go through the work of isolating one. And so we're going to have on this side, we're going to have the square root of x minus 2 plus 3. And we're going to multiply that to square root of x minus 2 plus 3. And that's going to be equal to, because this one's isolated, the squaring this isolated radical is just going to leave me with the radicand. So we're going to have 4x plus 1. So if I distribute on this side, this times this is going to be x minus 2 squared. Then we're going to end up with 6, the square root of x minus 2. And then we'll end up plus 9. So like I said, that's just me expanding this. Okay. So we had a square root here that was squared. So we're just going to be left with the x minus 2 plus 6 square root of x minus 2 plus 9. equals 4x plus 1. So if I just simplify this one side, I have x plus 7 equals, or plus 6, x minus 2. We have 4x plus 1. So we just need to isolate the radical. So I'm going to subtract x and subtract 7 from both sides. So we're just left with 6. The square root of x minus 2 is equal to 3x minus 6. Okay. And then if I divide everything by 6, then I'm just going to have x minus 2 is going to be equal to 1/2 x minus 1. So then we square again. So I have x minus 2 is going to be equal to, we're going to have 1/4 x squared negative x plus 1 after we expand this side. Okay. So because we got the square root of 4 here, what I could do is, so this, I'm not square root of 4, I mean, I got this 1/4 times x squared. I can actually take both sides and multiply them by 4. So I'm just going to end up with 4x minus 8 equals, and when I distribute here, I'm going to be left with the x squared minus 4x plus 4. So this was something we did quite a while ago when we were doing linear equations. It was how to deal with fractions, which was, if I have a fraction, just multiply everything by the denominator and I can get rid of that fraction. All right, so if I subtract 4x from both sides, I have negative 8 is equal to x squared minus 8x plus 4. If I add 8 to both sides, then I have 0 is equal to x squared minus 8x plus 12. So we can factor in that into x minus 2 and x minus 6. Those multiply to give me 12, but add to give me negative 8. So my possible solutions are is that x is either going to be 2 or it's going to be 6. The next part is we just need to check those solutions. Oops. So I'm going to check x is equal to 2 first. So I have the square root of 2 minus 2 plus 3 equals the square root of 4 times 2 plus 1. So we are going to have the square root of 0 plus 3 is equal to 8 plus 1. So we're going to have 0 plus 3 is equal to the square root of 9. So we end up with 3 equals 3. That checks out. So x equals 2 is a solution. And now we're going to check x is equal to 6, make sure that works. So absolute value of 6 minus 2 plus 3 equals the square root of 4 times 6 plus 1. So this is going to be the square root of 4 plus 3 and the square root of 24 plus 1. So square root of 25. And this is 2 plus 3. So this is 5 equals 5. So we also have another solution, which is going to be x is equal to 6. Okay. So let's work on B now. So B actually should have been fairly easy to do because we have two absolute value of x minus 1, square root of x minus 1 is equal to square root of 3x plus 4. So we have an isolated radical. So we're going to square it, and we're going to square it. So remember, this is a product and I'm squaring a product. So this is just 2 squared times the square root of x minus 1 squared. So really this is just 4. And because this is an isolated radical or isolated square root that I'm squaring, this is going to give me back x minus 1. And then it's 3, so this side is going to be 3x plus 4. So I have 4 is going to be equal, or distribute that 4, sorry. This is going to be 4 times x, so 4x minus 4 should be equal to 3x plus 4. So if we just solve for x, we get one solution, which is x equals 8. We just have to check that it works. So we're going to have 2 square root of 8 minus 1 is equal to the square root of 3 times 8 plus 4. Three times 8 plus 4, 28. Okay. So it might not seem like they're equal, but if you put in your calculator 2 times the square root of 7, that's going to give me roughly 5.292. And if you do the square root of 28, we are going to get 5.292. So these are actually equal. This is the simplified version of this side, is really all it was. So in fact, both sides are equal. So my solution is 8 equals x equals 8. So like I said, generally it's a pretty easy one, except for that very last part. You just have to plug it into your calculator or realize that one's the simplified form of the other one and that they're in fact actually equal.